Hi everybody, it's been several weeks now since I last did a video on my YouTube channel. The reason being is that I've been quite busy doing other work just lately and had little time to play with my electronics projects. But I thought what I'd do this particular video is look at an update on one of my previous projects. Those of you recall, back on my video number 31 we built this Milliohm meter, and what we're going to do today is look at upgrading this, building it into a smaller case, and also I'm going to use a little printed circuit board, double-sided print board, which is available to purchase. And this was actually designed by one of my subscribers, Greg Christensen, who very cleverly took my project and produced this double-sided PCB. So we'll have a look at that in more detail, and I'll show you how I went about updating the project and using this PCB. Let's have a quick look at the updated schematic for this project, and I'll point out some of the changes that has been made. We've added some additional decoupling, 100 nanofarad decoupling capacitors on the supply pin, the voltage supply pin for the IC. So you've got a 100 nanofarad capacitor there decoupling the LT3092, and also you have one here decoupling the supply for the Max 680 IC, the charge pump. In addition to that, we've added two 100 nanofarad capacitors there on the output, the plus or minus 10 volt output from the charge pump, to give some additional filtering. And you'll also notice that the four capacitors on the charge pump there have been increased now from 4.7 microfarads tantalum to 22 microfarads, and this time we're using normal electrolytic, low ESR electrolytics there. And this arrangement now has improved the regulation of the plus or minus 10 volts feeding the precision op amp. Now the other change we've made is, you'll recall that the resistor network we previously had on the output of the current source IC there, we originally had there 7 100 ohm resistors, and they've now been changed to 4 56.2 ohm precision resistors. I've used higher quality resistors there with a better temperature coefficient, and in addition to that, the series resistor that we had previously in series with the 100 ohm preset there was originally 56 ohms. That's now been increased to 63.4 ohms, and again it's a precision resistor. So these are the sort of changes that we've made to the circuit. Not a great deal of change. The essence of the circuit is still the same, but we've improved the stability of the circuit, and hence probably the accuracy of the output reading. Now you'll recall that from the original project we required a current source of 100 milliamps for our Milliohm meter, and that was achieved by using the current source IC LT3092, setting a precise 1.25 volt reference on the set pin, and that ensured that the output pin here was clamped at 1.25 volts. And therefore, in order to achieve exactly 100 milliamps on the output of this current source device, we needed to use a 12.5 ohm resistor. Now what we've done this time is, rather than use all them 100 ohm resistors, we've selected 4 precision 0.1 56.2 ohm resistors. These have a temperature tolerance of 15 parts per million. And if you put 4 56.2 ohm resistors in parallel, that'll give you 14.05 ohms. And what I also wanted to do is ensure that when we adjust the little 100 ohm preset there, that when it's in its center position, i.e. 50 ohms, I wanted the output to be exactly 100 milliamps. So you can see here what I've done is I've put a 63.4 ohm resistor in series with the preset. Let's assume the preset is set halfway, so it's 50 ohms. So 50 ohms plus 63.4 is 113.4 ohms. And if you therefore put that resistance in parallel with the 14.05 ohms, you get exactly 12.5 ohms. So it makes the whole resistor network here very accurate. We're using high tolerance resistors with a very good temperature coefficient. And I'll give you details of these in the parts list for this upgrade of the project. So there's the little bit more detail on why we chose those resistor changes for the Milliohm meter. Well, here we see now the new printed circuit board that we're going to use for this upgrade to the project. It's a double-sided print board. It's quite small, it's only about 6.5 centimeters by 4 centimeters. And this particular board was designed by one of my subscribers, Greg Christiansen, who goes under the name of Barbary. And it's very neatly arranged on this board because he's very cleverly put different parts of the circuitry segmented on different parts of the board. So in that area there you can clearly see we've got the charge pump circuitry giving us the plus or minus 10 volts. You can see the IC there with its 4 associated small electrolytics. On this part of the board here, this is where we've got the current source of the circuitry. There you can see the 4 resistors that we have in parallel. It says on the PCB 56 ohms, but as I showed you earlier, we're going to use 56.2 ohms. And the other resistor that goes in series with the 100 ohm preset will be the 63.4 ohm there. So there in the bottom corner is the 1.25 volt reference. Next to it you've got the current source IC, and then moving along here we've actually changed the 5 volt regular IC. Originally it was a TO220 package on the initial project. We've now changed that to a smaller package, the SOT223, and it now fits nicely on this little PCB. You'll see there we've got the via holes there in the middle going through to the other side of the PCB, grounding, and that also acts as a nice heatsink for the 5 volt regulator. Coming along here you can see that we've got the output circuitry here. There you've got the precision operational amplifier on the output together with the preset there, and the large capacitor in the middle is the main decoupling capacitor on the 5 volt power supply. So there we are, that's the board. The input and output terminal connections you can see at either side of the board together with the terminals for the meter, and the plus and minus 9 volts going into the board is there, and we'll be using a small 9 volt battery in this project today. Now I will point out that the presets going onto this board, you can see them going one there and one there. We'll be using this type of preset. It's a horizontal version of the preset with the pins coming through the bottom there, and then they'll sit nicely flush onto the PCB. But I'll give full details of that on the parts list, which you can download at the bottom of the video here. Now I'll just quickly turn the PCB board round. You can see the other side of the print. So there's the other side of the PCB. Nice grounding over the reverse side and a few tracks. So overall, nice pretty circuit board there designed by Greg Christiansen, and appreciate that. And that is available to purchase. I'll put a link down below because Greg has made it available through the website on the OSH Park website, which specialise in making open source PCBs. So I'll give you that link also on the parts list down below. I now have all the components mounted on the PCB, and you can just see how neat it is. The connections coming in there is actually the positive and the negative for the current source terminals, and on this side here you've got the yellow and the green there, yellow being positive, and they're the sense terminals. The two terminals you can see here again, yellow and blue, yellow positive, that's going to the panel meter on the front, and the power supply terminals for the panel meter, you can see I've got the negative one going there, and the positive one I've got going under the PCB and soldered on to the positive terminal of the large electrolytic there, which is the plus 5 volt supply. I'll turn that around and show you in a moment. Here you can see we have the connections there that are going to the 9 volt battery, and you can clearly also see the ICs neatly soldered onto the PCB and the precision resistor network here on the current source circuitry. So there's the printed circuit board all complete. I also took the opportunity in the output stage on the precision op amp to change the resistors here for precision resistors again. So all these parts will be covered and details in the parts list I will attach to this project. I'll just turn the PCB round and we'll have a look at how we've got the positive side for the panel meter, the power supply, connected. So I'll just turn it round, and you can see I've simply just soldered it on there to the positive terminal of the electrolytic. So that's giving 5 volts to the panel meter. Here we see the ABS case with a sloping front there, which I'll be using for this upgrade. I purchased this from Rapid Electronics, and again I'll give you the full details on the parts list detail below. The cost of the case, I think if I remember correctly, was around just over £6. Now the case itself comes in two parts, screws, but it comes with two front covers, so just remove the back, and the idea is that that could be used for a small LCD display. It's already pre-cut. You've got a blanking plate as well, which you could put on there, but in our case, because we're going to use quite a large display, I don't need to use any of these covers at the front. What we will have to do is we'll have to cut out the lip there that would normally support the panel. So I'm going to cut out that, and then I'm going to leave the bottom bit in, and then I'm going to cut a small piece from the bottom of that so it sticks along there just to finish it off, and I'll show you that in a moment. And then the display then will just simply slot in there. That's the display, the same display that we had previously for this project. Now the other thing I did for this update is I produced some artwork for this new case, the front panel artwork there, which again I'll give you as a download, and that's printed on sort of glossy paper with peel off backs with some self-adhesive on, which then will just stick onto the front there. But before we stick it onto the case, what I suggest you do once you've cut it out is position it onto the casing and then simply prick the holes through those cross points, remove the artwork, and then drill the holes on the casing, and then once that's done, then peel back the backing, and then that will then just stick on top, and then just cut out the holes. So that's the intention there. Now I'll be giving the artwork for this front panel as a download. It'll be a PDF file, but what I would suggest you do is don't try and print it directly from the web browser, the PDF file. What I'm finding is that when you try to print it directly from the web browser, the size of it is slightly smaller, and therefore it wouldn't fit perfectly on the casing there. So what I suggest you do is open up the PDF file in your browser, save it to your computer, and then reopen it up in your PDF reader and print it from there, and then you'll find it should fit fine. Now the other thing I've produced for this update is I've produced a drilling template for drilling the holes in the bottom of the casing to try and make it easier for you, and I've also indicated on the template the size of the drills that you require to drill the holes. What I would say to you is that when you're drilling the larger 8mm holes, I would suggest that you use a smaller drill first in the plastic, and then finally use the 8mm drill to finish it off. If you don't do that, you might find you start to crack the edges of the plastic casing, so just be careful of that. Now This is simply printed on the piece of A4 paper, and then simply you cut it out. And again, I would recommend that you download and save the PDF file to your computer, and then once it's cut out, fold it on the lines that are indicated there, and we're going to then use that as a template to mark and drill the holes on the bottom base plate of the casing. And I'll show you that in a second. Here we see now I've got my drill template folded, and once it's folded, then simply place it into the bottom part of the casing. It should fit in quite neatly with the fold creases then sitting at the edge. And what you have there now is the template for drilling the holes, and you can see the holes there for the PCB, and some other smaller holes there which we're going to use to mount the battery holder. Now we also need to have some holes at the top and also at the side for adjusting the presets on the PCB there. And what you do is, once you've got the drilling template inside, hold it firmly down and then bend the overlap over, and you can do that on both the side and also at the top. And once you've got the overlap bent over, what you then see is you've got drilling holes there, and they're in line then with the preset potentiometers for trimming the unit once it's assembled. And then at the top of the casing there, you've got 3 holes to drill. One is for a 2.1mm socket to plug in an external power supply, and then you've got 2 more there which allow you to put sockets on there to connect to another voltmeter. So that's the template for drilling the holes, and as I say, you can download that, print it off and cut it out. Again, once you've downloaded it, save it to your computer first before printing, and then open it up in your PDF reader rather than just try and print it from the browser, because if you try and print it from the browser, it shrinks the size slightly, so it's not the correct size, so just be careful of that. Here we have now all the holes are drilled. There's the holes for the PCB, holes there for the battery. I've just put a couple of little screws there to test that out. Just little self-tapping screws that tap into the plastic. We have the holes there at the side that line up with the trim pots on the PCB, and at the top end we have the larger 8mm holes for the socket and also for the little power jack there. So they're the all the holes completed. So what we'll do next is I'll cut the top part of the case so we can fit the panel meter in, and also we can drill the holes for the on-off switch and the connection sockets, and we'll have a look at that. Here we see a closer look at the 4mm sockets that we'll be using on the project. You can see there, as it comes apart, you've got a insulated shank there on it, and that would fit, in this particular case, an 8mm round hole on the casing. There you have the on-off switch, which is a latching push button, so press to on, press to off, and there we have the little DC power jack. It's 2.1mm centre pin. So that's the sort of, and again the details will be on the parts list. Here we now see the top of the case where I've mounted the artwork on the top there, the front panel. All the holes have been drilled, the sockets have been screwed in, and I've got a latching push button on off switch mounted there in the middle. So you'll see at the reverse side that coming through. You'll notice there that the on off switch, the terminals have had to just bend down slightly so to stop it hitting the back of the case. And as far as the meter display here is concerned, you'll notice that the top has been cut away, so that lip we had at the top there has been cut away. I've left the bottom one on, and what I've also done is cut a little piece of plastic with it's got a little bit of bevel on from the bits that they gave with this casing, and that will then just simply sit in there, and I'll glue that on with some glue. Having done that, the next thing is you take your panel meter, and that will simply then just push into that position there. So I'll just do that and we'll have a look. Right, well, the panel meter is now pushed in, and that fits neatly into the casing there, with the connection socket there, which then goes to the printed circuit board. Now in this version we'll be using a 9-volt battery, and I'm using this little 9-volt battery holder which will be fixed onto the base of the casing. Here we now see the base of the case, where I've got the external 4mm sockets mounted there, and the little DC jack socket there. The 9-volt battery holder is screwed into the board. I've just used some small self-tapping screws to fix it to the case, and there you can see I'm using some plastic or nylon nuts and bolts there screwed onto the casing, and that's where the PCB is going to sit on. So just tilt that, you can see that, and that's the underside of the case. So the next thing I'm going to do is position the printed circuit board, this area here, and fix that onto the casing. Well, there we now have the little printed circuit board mounted and fixed into the casing. I've just tightened it down with some nylon nuts, and that's fixed in position, and we've got nice access there through those holes to adjust those two preset trimmers. So I think the next thing we'll do, I'll do the wiring here, and then we'll come back and have a look before we assemble the front part of the casing onto it. We now have everything wired together. All the sockets are now wired up and the power. So the only thing we need to do now is fold it over and then plug in the plug and socket there onto the display. But just before I do that, I'll just zoom in and let you have a closer look at the wiring around here. Here we see the wiring around the power connector there. So what you have is you have the neutral, the negative side, going to that point there on the little power jack, and the other then going to the battery, and then the positive side there going to the battery, and that's also then going to the on-off switch, and then the other side of the on-off switch goes onto the board. Right, well, I'm now going to close up the case, and as I fold it round, I'm going to connect this lead here to the display. It's a little bit short, so you have to sort of fold it round and to plug it in. So let me do that. Here we now have the complete unit assembled. So the next thing to do is press the on-off button and see if it works. So let's see if the display comes on. That seems to be working fine, and we'll just go through the setup procedure. On the original project, you'll recall that I made up some test leads here for the Milliohm meter. I'm using the same ones, and so the first thing we're going to do is use these leads to set up the calibration on this meter. Right, well, here you see the two holes at the side of the casing there for setup. This one here is to set the 0 on the meter for the differential amplifier, and that's the one we're going to do first, and then the other hole there is to set up the 100 milliamp current. So let's do the 0 set there first, and we'll just have a look at that on the display. Right, well, in order to set the 0 of the sensing leads, which is the output of the op amp, you see the display at the moment showing 0.0003. We need to get that down to 0, and all we do for this setup procedure is we only put the connectors into the sensing sockets here and not into the current source, and then we simply clip the two leads together. So what I'm going to do now, so they're shorted out, I'm going to now adjust the trim pot to get a reading of 0 on the display. Right, well, as you see now, I've got the reading to give me 0, so that's set up. So the next thing to do is set up the 100 milliamp current source here. In order to set the 100 milliamp current, I've got the Milliohm meter current source sockets connected to a milliamp meter here on my multimeter. At the moment it's showing 99.99 milliamps, so I'm going to adjust the preset to give us exactly 100 milliamps. Well, as you can see from the reading now, we've got the meter giving us 100 milliamps. We can just trim it a little bit more to get exactly, we've got 0.01. So I think the next thing we'll do now, having set it up, we'll just check a few low ohm resistors. Right, I've now got all the leads plugged into the Milliohm meter, and so what you're seeing here, because the crocodile clips here are shorting out, it's reading overload or error, which is HHHHH. If I simply press the crocodile clips and open circuit that, it goes to 0. So what I'm going to do now is I'm going to put a 50 milliohm resistor across the terminals. So I now have a 50 milliohm resistor, and it's reading 0.050 or 0.0499 of an ohm, which is 49.9 milliohms or 50 milliohms. So I think the reading there is pretty good, really. So let me just check another resistor. This time we're looking at a 0.1 ohm resistor. So you can see there it's reading 0.1002 of an ohm. Well, I'm quite happy with this now. It seems to work quite well, and it's actually much neater than the previous version. It's certainly a smaller case and neater on the display. Remember also you have two sockets here, so you can actually connect it to a normal multimeter on the voltage range and get the reading in addition to seeing the reading here on the display. Well, I hope you found this update on this little Milliohm meter project of interest. I will be giving you full details you can download below. You'll be able to download the new updated schematic for this project, together with the artwork for the front panel here, and also the template for drilling the holes in the case. I'll also give a comprehensive parts list together with how to get hold of the PCB. Now, one thing I will say is that when you print off the front panel artwork and the drill template, make sure that once you've downloaded the PDF file that you save it to your computer first, then open it again and then print it from there, because I found that if you simply open it and print it from the browser, it tends to print it slightly smaller than it should be. So please remember that. Now, the other thing I would say is that one or two of you may have noticed that I'm wearing a Scullcom T-shirt at the moment. This little design was done by my youngest son, and I thought I'd have it made onto a T-shirt. So if anybody's interested, these T-shirts with the design are available on redbubble.com. Again, I'll put the link down below for anybody who's interested. Well, thanks again for watching. If you found this video of interest, please give me a thumbs up and subscribe, and I'll try and put you some new videos on my channel again shortly. Bye for now.